Check, check. Check, check. Hello. Check. Hello. Okay. Assalamualaikum Abdullah. How are you? Open the.
I'd like to introduce master's student Iskandar. Who's going to give a presentation on natural xenoliths of Harrat Uwayrid.
Okay. So is it better with the mask or without the mask? Take it out. Okay. Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillah wassalatu wassalamu ala rasulillah wa ala alihi wa ashabi wa man tabi'ahum bi ihsanin ila yaumiddin. Good morning, gentlemen. I thank you for your attendance, to the respected esteemed faculty members and also my colleagues, beloved colleagues from CPG. Today I will present my thesis proposal, which has a topic of the xenoliths of Harrat Uwayrid. Before continuing the presentation, I would like to take a minute of our time to introduce myself. My name is Okdarian Johan Iskandar. I am from Indonesia, known as Iskandar. And I'd also like to introduce my committee, which consists of my advisor, Dr. Scott Wattam, also Dr. Amau and Dr. Ardi as members. Okay. And I thank them very much for their attendance today. So this is the outline for my presentation today. It will generally be divided into 5 sections: introduction, literature review, methodology, preliminary results, and finally a tentative timeline of the study. So we will start with the introduction. Xenoliths are inclusion, seen in the picture, of mantle or lower crustal rock fragments brought to the surface by extrusive igneous rocks. They are among the few means to directly observe the Earth's mantle. Mafic and ultramafic xenoliths are regarded as fragments of the lower continental crust and upper mantle respectively. Shown here in the small figure that the lower continental crust and upper mantle is part of the lithosphere, and represented roughly by the gray color layer beneath the brown crust. They are transported to the surface via extrusion of basaltic magmas, predominantly alkali basalt of nephelinite and basanite compositions. The western part of the Arabian plate has exposures, significant exposures of Neoproterozoic continental crust, which comprises the Arabian Shield. Here is represented in the figure by the orange color. Among younger rocks that cut the Arabian Shield are Cenozoic aged alkali basalt fields, known as Harrats. These Harrats represent one of the largest basalt fields on the earth and extend from the north to the south along the coast of the Red Sea, covering parts of Syria, Jordan, the Kingdom of Saudi Arabia, and Yemen. These extensive lavas, represented as the red colors on the image, has been interpreted as volcanic products related to the rifting of the Red Sea. These Cenozoic Harrats contain abundant mafic and ultramafic xenoliths, and studies from various lava fields in Syria, Jordan, Saudi Arabia, and also Yemen have produced insight to their characteristics and implications. The problem statement for my study is that large volumes of the xenolith-bearing Harrats lie within Saudi Arabia. A total of 12 of these Harrats are reported in Western Saudi Arabia, and they are represented by the red color with the greenish outline. 9 Harrats in Saudi Arabia, Western Saudi Arabia, has been identified to be xenolith bearing. However, whereas some are well studied, others are less explored. Analysis of mantle and lower crustal derived ultramafic and mafic xenoliths located within Saudi Arabia has been performed, although studies of the latter, which are the mafic xenoliths, are relatively limited. Published detailed xenolith data are limited to 5 lava fields, Al-Birk, Al-Kishb, Khaybar, Hutaima, and Uwayrid, which will be the area of study. As significant time has passed since many of the studies were performed, and advancement in technology has led to improvement in analytical instruments and techniques. Therefore, opportunities exist for further studies of these Harrats and the xenoliths within them. The study has the following objectives: petrographic study to determine mineralogy and rock classification of the xenoliths in Harrat Uwayrid, bulk rock chemistry by ICP, OES and MS analysis to determine major and trace elements of the xenoliths, and mineral chemistry by EPMA probe to measure major elements of the xenolith minerals. So the study area, which is Harrat Uwayrid, is located in the northwestern area between the city of Tabuk and Al-Ula, lying between the administration division of Tabuk region and Medina. From satellite images, we may observe that it seems that Harrat Uwayrid is one body with Harrat Ar-Raha, but from literature, it is mentioned that there is a division here, which is indicated by the yellow line in Al-Um area, which divides between Ar-Raha and Uwayrid. Therefore, Harrat Uwayrid is the southern section of the volcanic body. We will start the second part of the presentation, the literature review. Harrat Uwayrid, as established in the introduction, is one of the 12 intraplate Cenozoic volcanic bodies located along the western margin of the Arabian plate. The structural trend of the Harrat body, Uwayrid itself, has a trend of north 30 degrees west. This trend is interpreted as parallel to the Najd fault system orientation and also the Red Sea axis. The lower host lavas of Harrat Uwayrid and underlying Paleozoic sandstone, as you can see, the lavas with the dark color and the sandstone, the Paleozoic sandstone with the brownish color, has an angular unconformity contact. This suggests that the formation of the Harrats postdate the tilting events in the northern shield. In addition, contacts between the igneous and the sedimentary rocks are observable throughout the volcanic field. And in this particular picture, we can see that the contact is represented by the dashed orange color line. So here we have a figure from Alter 2019, and it indicates or shows the division of age in the Harrat body of Uwayrid. the light color being the older age, and the dark orange color being the younger age. Potassium argon dating from author 2019 provided 2 age distinctions within the body of the Harrat Uwayrid. Upper Miocene for northwestern and south plateau lavas, as we will see, and Pliocene to Quaternary age for central scoriaceous rock. So figure B, image B, shows Google satellite image overlain by the division of the ages by author 2019. The older rocks, again in the northwestern and southern section, comprise of plateau lavas, as we will see later, which are exclusively lavas of alkalic basalt. Howaites, more specifically Howaites, basanites, and rare transitional basalts. Whereas the younger rocks, which are the central part, dark orange color, primarily scoria of basanite and their fractionated equivalents, and are in central section and characterized by bombs and lesser lava flows. So previous studies of xenoliths within Saudi Arabia have been found amount to 12, and starting from the publication in 1980 until the most recent in 2019. As we may observe, the location of the xenolith studies may be restricted only to one specific Cenozoic Harrat body, or it may consist of multiple xenoliths from the various bodies, Harrat bodies in the kingdom. Data presented are usually petrography or rock chemistry, mineral chemistry, thermobarometry, isotopes, and lithologies that were identified within those bodies. As mentioned earlier, the detailed xenolith studies are restricted to these 5 Harrat bodies with the blue color, dark blue color, whereas the light blue color indicates xenoliths that are studied but may be included in one of the literatures here. And also the numbers within the small square inside is indication of how many times the xenoliths were mentioned within each literature. So studies of xenoliths of Harrat Uwayrid itself are concentrated or within 2 studies. First is studies of Hengen Kunst in 1990, and also Kaliwoda in 2007. The summary of Hengen Kunst et al. 1990 studies are displayed in the table, but the study concluded that Harrat Uwayrid xenoliths, among other Harrat xenoliths, have lithospheric origins. The mantle from which the xenoliths originate was subjected to 2 metasomatic events and inferred related to the development of the Red Sea. Xenoliths produce an isochrone of the age 700 million years ago, corresponding to the age of the early crustal formation of the Neoproterozoic crust, Arabian Shield. Sorry. This is the summary of Kaliwoda's study in 2007. The study concluded that xenoliths of Harrat Uwayrid originate from the depth approximately 35 to 60 kilometers below the surface. There were 3 thermal stages that were subjected to the mantle, which are simple cooling, cooling followed by heating, and simple heating. And these thermal evolution was suggested that the upper part of the lithospheric mantle beneath Harrat Uwayrid was subjected to regional heating originating from the Afar plume activity, followed by slow cooling, and then the second heating came from a regional event, which is interpreted as exposure to stagnated or rising magmas. So the methodology for the study will be summarized with this flowchart, simple flowchart, and has 4 sections. Sample section consists of field work, collecting rock samples of host basalt and xenoliths, then preparation, which consists of documentation of these samples, cutting them, and also thin section construction. These samples are then perform analysis on them. So 4 analyses will have been done and will be done which are microscopic analysis, XRD and ChemScan, ICP and ICPOS and ES spectrometer, EPMA or probe. Microscopic analysis along with XRD and ChemScan will provide petrography data, whereas mass spectrometry will produce bulk rock chemistry, and EPMA or probe will produce mineral chemistry. From this data, we will interpret rock classification, pressure and temperature conditions, tectonic setting, petrogenesis, thermobarometry values. And finally, along with the literature study, we will provide a discussion and also conclude. So therefore, outcome that is expected from these studies are determination of petrological classification of Harrat Uwayrid xenoliths, a petrogenetic history of the xenoliths itself, interpretation of the lithospheric mantle setting beneath Harrat Uwayrid, and comparison of the study results to other Arabian xenolith studies. So the fourth part of the presentation will be preliminary results. Field work performed in late 2020 under guidance of Dr. Scott and Mr. Mutasim and fellow colleagues in CPG resulted in 25 locations visited. And this resulted also in acquisition of 66 rock samples, and among them 36 xenolith samples, as you can see in the map here. Also, the spreading of the stop location shown over Alta 2019 indicate that we have visited the 3 sections in the north, the central, and the southern area. A brief overview of the location visited and their typical morphology and samples is starting from the northwest area section of Harrat Uwayrid, which is characterized by the plateaus, as we can see here, although maybe not too pronounced, but we can see that the plateaus from on top of these mountains. And this is the host basalt that we most commonly meet during the collection. And then we will jump to the south, which has the same age, the upper Miocene, which also here we can observe more clearly the plateau morphology of the lavas, and also similar characteristics of the host basalts, although we found xenolith within the host basalts in the southern area. And finally, the central cinder cones, which is younger in age, Pliocene to Quaternary. Unlike the previous 2 sections, here the central is associated with cinder cones, and also the basalts are scoriaceous and are abundant in xenoliths. So most of the samples were collected within the central area of the Harrat. So host basalt petrography and chemistry. So these are the divisions of within the Harrat body, and this is a typical older host basalt, and this is a typical younger host basalt found in the central area. Here we provide petrography images, thin section images that validate our findings, that starting from the older host basalt, the petrography images and in the middle inside them confirm that these are basanite lavas, Hawaiite lavas, and alkalite basal lavas. The image on the top are thin section images from the younger host basalt, and again they provide validation that these are basanite scorias and basanite lavas. I would like to emphasize that we found 2 locations which which is shown here with the yellow color outline at the bottom. 2 locations which was not previously mentioned in the original literature, which has subalkali basalt lava composition. Here we provide TAS, total alkali versus silica diagram to show the classification of geochemistry of the rocks that were collected, of the basalt rocks collected in the field. So they are categorized as basanite, Hawaiites, basalt, and these 2 are the category of the subalkali basalt. And finally, Here is a table of zirconium ratios against yttrium and niobium, and indicate that the samples have or characterized with geochemistry akin to enriched morph. Whereas the two squares here, which are the hopefully the newly discovered locality, are laying or fall in the category of transitional morph. We will continue with the xenoliths. So sample documentation was performed on the xenoliths to record their textural description. Sample preparation was done on the xenolith samples. They were cut and divided into small pucks, which were used for thin section construction and also geochemistry analysis. 18 thin section were constructed, whereas 11 geochemistry analysis were performed. And here, selected thin sections images from the xenoliths of the central region. And here, after semi-qualitative analysis from petrography, by petrography microscopic, the thin section displays 65%, approximately 65 to 80% olivine and approximately 20 to 30% pyroxene, or orthopyroxene and clinopyroxene, along with 5% spinel. As you can see, the spinel with the brown color, also the olivines within the thin section, also orthopyroxene with their cleavages. Also here is images from the thin section of the xenolith sample in the southern section. Also has the spinels, the orthopyroxene or clinopyroxene, and also the olivines. So quantification of the percentages of the olivine, the orthopyroxene, and the clinopyroxene within the xenoliths were used to classify these xenoliths. And the xenoliths that we collected for the field of Harrat Uwayrid currently fall under lertzolite. And the additional spinel, which will amount to 5%, was added to the terminology, and the xenoliths collected are classified as spinel lertzolites. So finally, bulk rock chemistry was also produced, and here ratios of major oxides composition against magnesium oxide was plotted to demonstrate the differences in major oxides quantity of the xenolith samples. The tentative timeline of my study will be literature review until April, and petrography. We are in January. Sorry, we are in January now. Petrography analysis has been performed, but hopefully will be revisited. The samples, the thin section itself is now undergoing EPMA analysis in Korea, and hopefully once received, we will continue with ChemScan and XRD analysis, and then continued by thermobarometry analysis calculation. And during the duration of the analysis, data interpretation and thesis writing will be performed. And by the month of May, hopefully we will do the thesis defense. So these are references from my presentation. That is all for today's my presentation. Thank you very much. Oh, okay.
Really good presentation, and I thank so many people for coming. So, anybody has questions?
Yeah, this is something I should probably know, but are there matching Harrats on the Nubian shield side?
Yes, doctor. On the other side, right, doctor? In the African continent. To be honest, I have not researched this in detail, but I have been reading and also asking colleagues. They have not, as far as I know, there have not been any matching results in the other side of the Red Sea. Yeah. Okay, adopted by alpha. This one? Yeah. Yeah. So I've asked the colleague, or discussed about this with my colleagues. They say that there are also like, but there aren't any cinder cones that are associated with the xenoliths at the other side of the Red Sea, as far as I know. Yeah, welcome. Thank you for the question, Doctor.
I should say nice presentation also. Very well done.
Thank you very much.
Okay, yeah, thank you, Standard. I just, again, most of what you're telling us is beyond my. So I was wondering, you have different vessel fields.
Yes, yeah, Doctor.
So are they, what control these two different?
Okay. Regarding the ages of the tectonic events that resulted in this the different post basalt ages, this will be probably currently under study also by Dr. Scott. To be exactly sure what it was, what caused it, I'm not pretty sure myself, but it again it's generally related to the Red Sea rifting. To the Red Sea, still to the Red Sea rifting. Yes, that's right.
And from your proposal, you have element.
Yes.
Are you planning to?
Yes, Doctor. So one of the, let me just skip to the diagram. Okay, so the rare earth elements from the bulk rock chemistry, actually from the bulk rock chemistry probably will be used to infer one of these interpretation. So yes, it will be provided with the REE diagram or the multi-element diagrams. So yes, probably we will use the trace elements for tectonic settings or heterogenesis.
Okay, because one thing that I didn't quite get is, do you have any like prior hypothesis that you are trying to test your study, or are you trying to describe the xenoliths?
Yes. So the original was trying to describe the xenolith itself, but after literature study now I have a general idea of what to compare and what to expect from the xenoliths that are currently available in Harrat Uwayrid. Okay.
Like what you said, that Uwayrid is already well studied, right?
Yeah.
So I just want to know what is actually the gap in our knowledge now.
Yes.
Why you selected Uwayrid?
Harrat Uwayrid itself is, as you mentioned, you are correct, Doctor, that it has been studied in detail. One of the studied in detail, but also the data provided by Kaliwoda, which was by Kaliwoda in 2007, still have gaps, which includes the whole rock chemistry, and also the petrographic descriptions are quite in detail. So therefore, these hopefully the study can provide additional data regarding the petrography description and also the whole rock chemistry interpretation towards Harrat Uwayrid itself. Xenoliths.
Just one more question. Can you go to
Yes, the final one is.
just very quickly?
Yeah.
Is there anything you can tell us more about this crosstalk?
So regarding this cross spot myself, to be honest, I need still additional information. I mean, learning regarding interpretation, but most probably later the interpretation will come from specific plots of specific elements. But here, the most common that is in my knowledge is that magnesium oxide compared to silica oxide is the fractionation of the rock itself. So, for example, here the silica is between 50%, 40% to 50%, which indicate ultramafic composition, which ultramafic composition is 45, with increasing silica and decreasing of magnesium, silica oxide and decrease of magnesium oxide. It indicates that there might have been extraction of melts from the xenolith itself, because within the mantle. So here, because the silica oxide and the magnesium, the plot here indicates, it doesn't show any specific, what do you call this, relationship. Therefore, this is interpreted as more or less the same stage of evolution for the rock itself regarding its fractionation. Yeah, as far as I know, this was the main one I still currently understood. But also I should have included calcium oxide against aluminum oxide, which indicates how far that the fractionation between primitive earth to extracted or depleted mantle xenolith. So yeah, doctor, as you mentioned, this just currently demonstrate the different quantities of the oxides within the bulk rock chemistry itself. So I haven't interpreted too much regarding the rock chemistry itself.
What's really striking to me is the aluminum oxide and the calcium oxide. And
Yes, titanium oxide. Yes,
they have sort of
relationship. So yes, right. Yeah, actually, I do have an image in my mind also regarding this, but I'm still not confident enough to explain regarding the relationship between magnesium oxide with the aluminum oxide and calcium oxide. So you're welcome, doctor. Thank you for the question, doctor. Yes. Oh, please. Yep. This one. This one. Let's see. Okay, yes. 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 Yes, xenolith areas are barren, yes. Again, yeah. Well, let's see. I have also been reading regarding this. So the middle section, which comprises of where the basalt comprises a lot of these xenoliths, are associated to basalts which have scoriaceous textures. This indicate for me that basalt itself, they are non-viscous, less viscous than the mafic magmas. Therefore, they contain a lot of volatiles during their ascent because they're scoriaceous texture. Therefore, it indicates what do you call it? A quick ascent from the deep depth to the surface. Therefore, probably with enough velocity to rip or take the xenoliths from the lower mantle. Regarding the implication, there should be the implication, as Dr. Ardi has suggested, regarding why there is this division within the body. But maybe it's due to my less reading, but hopefully by the end of the study, we will have an answer regarding this. Okay, thank you very much, Abdullah. Yes. Okay, this is a good question. Yes, we did separate the xenoliths. So, it's the okay. So as you can see here, in this sample documentation, we see the xenoliths still entrained in the host basalts within the green color. And some are already separated from the host basalts. But after the cutting of the xenoliths, they were separated from the host basalts, and just most of them, the one that are abundant, could be performed both the thin section construction and also the geochemistry analysis. Yes. Yes, that's right. Currently, the classifications are under based on the semi-qualitative petrographic analysis distribution of the minerals are still correctly currently classified generally as spinal larzolites, but from the color of the xenoliths itself, they vary, so dark green, light green, which in my limited knowledge might indicate pyroxene domination or the olivine domination. So with additional data from the ChemScan and the XRD, hopefully it will provide further constraint regarding the separation of the classification. Thank you, Abdul. Okay. Yes. Yes. Thank you again. Thank you very much for the suggestions from Dr. Adi Abdullah and questions, also the attendances from everybody. Maybe I will return the presentation to Dr. Scott.
Thanks a lot again for such a large amount of stuff.
Thank you, Dr. Adi. I'll see you. Inshallah. Dr. Rahman, thank you very much. Sorry for yesterday, maybe.
It's good.
Thank you.
Actually learned a lot.
Thank you, Amma. Oh, thank you. You're welcome. Thank you very much, Dr. Sasim. Abdullah, thank you very much for the suggestions, inshallah. Thank you very much.